At the end of the last video, I left you with this problem. Here's a point in polar coordinates. We want to find the rectangular coordinates. Okay. Now, last time I sort of started with a graph and then I double checked with the formulas. I think this time I'm going to do it the other way. I'm going to start with the formulas, which, oh my goodness, I erased. Now, I'm going to pretend that I have forgotten the formulas. And I'm going to remember that I can get them by working with this triangle. This triangle would represent the simplest choice of polar coordinates for a point P up here that would be in quadrant 1. Okay. And so if I look, I can see the relationship here is that cosine of theta is x over r, and that means that x is r cosine theta. And sine of theta is y over r, and that means that y is r sine theta. Okay. I recommend just having this triangle drawn anytime you're using the conversion formulas. You may very well memorize these or accidentally memorize them just from using them so often, but it's kind of nice to make sure that you understand where they come from, because quite possibly you're going to accidentally forget them at some point after accidentally memorizing them, and if you understand where they come from, you can always get them back. Okay, so if I use these formulas, x would be r cosine theta, so that's 3 cosine of 5 pi over 6. So that's going to be 3, and then finding cosine of 5 pi over 6 would be a two-step process. Here's 5 pi over 6 landing in quadrant 2, so cosine is negative. The reference angle is pi over 6. If I draw a quick 30, 60, 90, which may or may not be necessary for you at this point, pi over 6 is 30 degrees. Cosine would be root 3 over 2. So my x value, I can see, is negative 3 root 3 over 2. All right, y is r sine theta, so that's going to be 3 sine of 5 pi over 6. So that's 3. And then since we're in quadrant 2, pi over 6 is positive, sine is positive. Pi over 6 is again the reference angle. Sine of pi over 6 is just 1/2, so my y value is 3/2. All right, so that's what I get just plugging into the formulas. What I'm going to do is this makes it look like I have plotted a point, negative x, positive y. I think I plotted a point in quadrant 2. Let's just do a quick double check that that should happen. If my angle is 5 pi over 6, that does land in quadrant 2. Positive r value says go in the positive direction. So I've got a point that's going to be somewhere there-ish. That definitely looks reasonable. Okay, I'm liking it. Let's try one where we go the other way. Let's start with rectangular coordinates and go to polar. So let's say I have xy is negative 1, 1. Okay. And I'm going to remind myself that here's my triangle that helps me to remember my conversion formulas. The Pythagorean theorem gives me x squared plus y squared is r squared. And if I want, I can simplify that to r is going to be one of two things, plus or minus root x squared plus y squared. And then I get that tangent of theta, opposite over adjacent, is going to be y over x. Okay, you'll notice that's actually the circle definition of tangent. Okay, and that works for any circle regardless of what the radius is. Kind of cool. Okay. Now, when I'm working with this, I'm going to just find a pair of polar coordinates for this particular point. Okay, so if I'm looking here, if I plot this point, negative 1, 1 would be right about here. So I've gone 1 over and 1 up. And so I can see the simplest choice, I think, for r and theta would be to let r be positive and let theta be this obtuse angle. Okay. If I'm not told otherwise, I always choose r positive so that theta lands in the quadrant that I want to work in. That's just simpler. Okay. So if I take a look, just labeling the side lengths of this triangle, those would both be 1. Okay. Pythagoras gives me that that's going to be root 2. So I could say r theta is going to be root 2. And right now I have committed to my theta being an angle in quadrant 2. Okay. So I can see, if I use this formula, tangent of theta is going to equal 1. Sorry, it's going to equal -1 because we're in quadrant 2. Okay. But I can't take arctan of -1 because that would give me an angle in quadrant 4. And by choosing r to be positive, I've committed to choosing theta to be an angle that lands in quadrant 2. So this needs to be true, but this also needs to be true, that I've got to be in quadrant 2. What I can do is say, let's figure out alpha. Let's figure out our reference angle. Tangent of alpha would be the absolute value of -1, which is 1. I can use arctan for that, but I should recognize the angle whose tangent is 1 is pi over 4. So alpha would be pi over 4. Theta is pi minus alpha. So that would be pi minus pi over 4, or 3 pi over 4. Not something I could get using inverse tangent. I had to look at the fact that I was in quadrant 2. Okay, so I'm going to give you folks one to try. And again, try this on your own before tuning into the next video. But let's suppose that I know that xy is -2, -2 root 3. Okay, and I want you to find, I'm actually going to make this one a little bit tougher. I want you to find 4 coordinates for me. 4 pairs of coordinates. First of all, choose r and theta to both be positive. Then choose r to be positive, but theta to be negative. Then choose r to be negative and theta to be positive. And then choose r to be negative and theta to be negative. Okay, so come up with 4 pairs of polar coordinates for this point. Definitely start with the first one. The first one's going to be the simplest one. There you're choosing an angle that lands in the appropriate quadrant, and you're choosing your r value to be positive. Once you've got that, you should be able to modify that. Okay, excellent. So I'll see you in the next video.